Hello everyone. This is a continuation of lesson 2.1. So in the previous video, we talked about the different types of angles. So we have acute, right, obtuse, straight angle, reflex angle, and the one complete rotation angle. So this time, as an exercise before you proceed watching the video, I want you to do this part here. With the use of a protractor, you try to measure the following. So you try to measure this angle here. So that means that you measure from here to here. What would be that angle measurement, as well as the angle measurement of the other side. Okay, as well as the others. Again, this angle here, here, and this particular angle here, and these different angles here. So angle R, angle Q, and the angle P. So you try to do that, and you can actually pause for a while, and with the values that you get, if you're gonna add all of the angles, try to write what would be the sum. So therefore, what would be the sum of all the angle measurements that you've done in the figures A, B, and C. So again, try to do that one first, and then you try to pause the video. Okay, welcome back. So if you have measured using a protractor of these three different figures here, and you take the sum of all the angles, so for letter A, you take angle X and angle Y added together, you should get an answer of 180 degrees. A plus B is also 180 degrees, as well as the sum of P, Q, and R. It should give you 180 degrees. So angles on one side of a straight line, so based on the results that we have, we can say that the angles on one side of a straight line, so as long as that is a straight line, it will always add up to 180 degrees. So one side, important thing to note, so the sum, they're lying on a straight line, the sum will always be 180 degrees. And we call them, if we have two angles that will add up to 180 degrees, we call them supplementary angles. Okay, so we call them as supplementary angles. So they supplement of each other. So in the previous figure, X and Y are supplementary angles, as well as A and B. So A and B here are supplementary of figure B, and in figure A, this shows X and Y are supplementary angles. So let's take this example here. So what would be the measurement of my angle A? Well, angle A would be, remember that this is a straight line. Well, this is a straight line here. So therefore, if that is a straight line, the sum would be 180 degrees. So that means that angle A would be 180 degrees minus 155 degrees. So where did you get 155 degrees? Well, this angle here, so from here to here, that's 155 degrees. So that is where you get your 155 degrees. So Therefore, angle A would be 25 degrees. Okay, that would be 25 degrees. So let's take letter B here. What would be its angle measurement of your angle B? So that means that this particular angle measurement here, that would be your angle B. So how would you get the answer of your angle B? Again, if you can see, this would be a straight line. So this is a straight line. So if this is a straight line, the angles that would be lying along that would take the sum of 180 degrees. So therefore, angle B would just be equivalent to, again, the sum is 180 degrees in total. However, this would be minus 51 degrees minus 68 degrees. So therefore, your angle B would just be 180 subtracted with 51 and 68 degrees. So if you're gonna do that, that would be equal to 61 degrees. So that B is, this angle B here is 61 degrees. Again, to check, you can just take the sum of 61 plus 68 plus 51. It should give you 180 degrees. And for letter C, if you can see this figure, you're given only this angle here. So this would be 80 degrees. Okay? However, based on what we know, as long as it is lying along a straight line, so if I'm gonna draw a straight line from where the angle measurement started, so this is a straight line. So if you can see, if this is a straight line, angle D is just a supplementary of that 80 degrees. So that means that this particular angle measurement here is just 100 degrees, because 100 plus 80 is 180 degrees. Okay? So that would be 100 degrees. If that is 100 degrees, if you can see, again, I can also draw another straight line upon which it touches the C and E, or that particular two angles. So this is a straight line. So that means that if D is 100 degrees, that also follows that this angle here from here would be 80 degrees. So angle is 80 degrees because, again, this is just a straight line. The straight line will give you an angle of 180 degrees. And another one is the angle C. What is that angle C? Well, is it that angle C just lies along, well, you know, have several options there. Either you choose this green straight line or the orange straight line. But in both cases, you see that this particular angle is 100 degrees. So it's 100 degrees. Again, how did you get 100 degrees? Well, that would be 100 plus 80 is 180 degrees. So for letter C, actually it will lead you to the next angle relation that you can make. So these are what we call the opposite angles at a vertex. So opposite angles at a vertex, we also call them as vertically opposite angles. Okay, vertically opposite angles. So if you have two straight lines which crosses an X shape, so that would be, if you can see in this particular case, you have the uh, straight line, straight line here. That would be one straight line and straight line, and then you have the other one straight line. Okay, so the point of intersection between these two lines is what we call the vertex. So the vertex is here. So this is what we call the vertex. Okay, that would be a vertex. So again, the vertex is just the one, the point where the two lines cross. So the point of intersection is what we call the vertex. Okay, so in the diagram, P and Q are opposite angles at a vertex. So if you can see, this particular angle P and Q are opposite to each other. So opposite in reference to the vertex, as well as you have the R and S. R and S are also opposite to one another. So they're opposite angles. Again, we refer in reference to the vertex. Okay? So if you can see, you can relate this one with our previous uh, example. So if you can see, C and D are opposite to one another. They're opposite to this vertex. This is the vertex because this is a point upon which the two lines, straight lines, intersect with one another. And if you can observe, this angle here is the same as the angle above, as well as the angle at the side is equivalent to the angle at the other side. So, if you can see, if you have vertically opposite angles, they're always equal. Okay, so opposite angles at a vertex are equal. So, I want you to, again, with the use of your protractor, you can actually verify that one, if indeed they are, if this is true. Okay, so like for example, this C and D are vertically opposite to one another, as well as your A and B. So in the second figure, S and T are opposite to one another, and U and V are opposite to one another. So with the use of your protractor, kindly check whether A and B are equivalent, as well as the C and D on the first figure, as well as U and V, if indeed they're equivalent, or S and T. So again, we can verify that one if they are indeed equal with the two figures above. So vertically opposite angles at a vertex are always equal. Okay? So just to take note that the word vertical or vertically refers to the vertex. So again, in reference to the vertex, and nothing to do with vertical lines. Okay? Or vertical. So again, it's just vertically when we say vertically opposite angles, that means they're in reference to the vertex. Okay, so another angle relationship is the angles around at a point. So angles around at a point. So again, in the case of letter A, in this particular case, you try to use a protractor to measure the following. So F, how would you measure this angle F here? So angle F is just the angle from here to here. So that would be your angle F. You also try to measure what would be this angle E. So angle E is only from here to where the angle F ends. So that would be your angle E. Okay? So that you use your protractor, you try to measure that, that would be your angle E. And then angle G. So angle G is the angle between here up to the starting of your angle F. So that would be your angle G. As well as you try to do the following. Well, if you can see here, these are not straight lines meeting one another. So this is not the same as the previous one. So in this particular case, at a point, but all of them, they have a common vertex. Okay, they have a common vertex. However, it's unlike before that you create two straight lines intersecting to one another. But here, if you can see, they have a common point, they have a common vertex. However, obviously this is not a straight line, as well as this one here. However, all of them have a common vertex for all of the angles. So therefore, in this particular case also, try to measure this angle here. That would be your angle M. Again, this would be your angle P. So angle P is only from there to there. And then angle N is this angle here. And then angle Q would be the angle of so angle Q is this angle. So you try to do that in your protractor. You try to use the protractor and take the angle of each. And if you're gonna take the sum of all the angles, okay, so hopefully again, before you try to continue this video, try to pause it and try to measure each. Okay, welcome back. So if you're gonna take the sum of all the angles here, E, F, and G, hopefully you get an answer that is close to 360 degrees. As well as M plus N plus P plus Q, it should also give you 360 degrees, okay? And if you can see there, this is just actually a particular case wherein you have one full rotation. So from here to here, that is just one complete rotation. And one complete rotation is just 360 degrees. So same thing with this one. Whether you move counterclockwise or clockwise. So if you can see, this is just one complete rotation. So that is just one full complete rotation. So that is just 360 degrees. And again, based on this particular example, it's always the angles around a point will always add up to 360 degrees. So that would be 360 degrees. So the sum. So the angles around a point add up to 360 degrees. Okay, so let's take this example here from your text. So again, if you can see, you have several angles there. However, they have a common vertex or a common point, okay, between the different angles. And if you're given 52 degrees, 57, 71, and 80, and you want to get your angle A. Angle A is this angle here. So this time, even though you don't have a protractor, you can measure that particular, you can determine angle A by knowing that the total angle measurement around a point is 360 degrees. So that means that if I gonna add A plus 52 plus 57 plus 71 plus 80 degrees, that should give me 360 degrees. Or that tells me that angle A is just 360 degrees subtracted to each of the angles. So minus 57 degrees, minus 71 degrees, minus 80 degrees. So therefore, angle A is just equal to, so again, angle A is just equivalent to 360 minus 52, minus 57, minus 71, and minus 80 degrees. So that should lead you to an answer of 100 degrees. Again, in this particular case, no need to use a protractor because now you know that for the sum of the angle around the point is 360 degrees. Okay, so let's take the second figure here, the second diagram. We want to know these two angles here, so C as well as angle B. Okay, but this is a little bit challenging because we know that the sum of everything is 360 degrees, but you have two angles that doesn't contain any value. So unlike in the first one that we only have to get angle A, here you have two angles that are unknown. So we make use of the things that we know in the previous discussion that we have. That in a straight line, so if you can see here, this is exactly a straight line. This is just a straight line. So we know that in a straight line, the angle measurement of such, so that means that this angle measurement from here to here, or actually it also follows that from here to here, that's 180 degrees. So this is 180 degrees, as well as the previous one, again, the orange, this is also 180 degrees. So if you can see, that means that angle B, so using that relation, that the sum of B and 120 is 180 degrees, I can say that this is just 180 degrees minus 120 degrees. Okay? Because again, the sum of B and 120 is 180 degrees. So therefore, B is just 180 minus 120 degrees, and that gives me 60 degrees. So therefore, angle B is just 60 degrees. And if that is 60 degrees, what is the angle or the measurement of angle C? Well, you have several options here, because now you know angle B, that this is 60 degrees. Okay, I can just make use of the 60 plus 55 plus C is 180 degrees, or same thing, B plus 55 plus C is 180 degrees. So if I'm gonna do the first one, I'm gonna make use of this straight line, 60, 55 plus C. So I know that if I'm gonna add 60 degrees plus 55 degrees plus C is 180 degrees. Or from there, that means that C is just 180 degrees minus 60 degrees minus 55 degrees. So C is just equal to, so that would be 180 minus 60 minus 55. So that gives you 65 degrees. So C is just 55 degrees. Okay? So if you want to check your answer, if this makes sense, so to check, that means that if you're gonna add everything up, remember, this is just angles at a common point. So that means that if I'm gonna add everything up, that should give me 360 degrees. So I can check by adding 120 degrees, 60 degrees, plus 55 degrees, plus, again, 60 degrees, and plus 65 degrees. Okay. So if I'm gonna do that, that should be, so I should expect that the answer is 360 degrees. So 60 plus 55 plus 60 plus 65. So if you can see, that is 365 degrees. So indeed, my answer is correct. Okay. So as a seat work, you try to answer. Okay. You need to submit this one. You answer page 86, number 1. Okay, so kindly submit this one, show your work, show your solution, and submit it in the Google Classroom. Okay.